Specialist Mathematics, Paper 2, Tech Active from 2023. We're going to do question 17. Big question, 6 marks. Projectile motion. An object is projected upwards from the ground level with initial velocity of 15 meters per second at an angle of 54 to the horizontal. The object just passes over a drone hovering in the air. An observer positioned directly below the drone at a horizontal distance of 20 meters from where the object is presented and made 2 comments: that it took around 2 to 2.5 seconds after its projection to reach the drone, and the object was still moving in an upward direction as it passed the drone. Assuming that air resistance is negligible, use vector calculus. Okay, I'm a picture person. We have, it's been projected. Don't know what's happening to it. I have a drone. And then I have a person who's directly below the drone. Now this distance is 20 meters. I know my angle was 54 and it was traveling at 15 meters per second. I like that. So my initial velocity is 15 cos 54i plus 15 sine 54j. Straight up. The acceleration is negative 9.8 j. Straight down, we've got our gravity. So our velocity is the integral of that. So our velocity is negative 9.8 tj plus c. Fairly standard start for a projectile motion question. Going through. We need to find c. So we know that when t equals 0, v equals vo, doesn't it? Our initial. So 15 cos 54i plus 15 sine 54j is equal to 0 plus c. So that's obviously c. So therefore v equals negative 9.8 tj plus 15 cos 54i plus 15 sine 54j. Now I know there's some people who would work out 15 cos 54 and put it as a decimal, and same with 15 sine 54. That's fine. I just like the accuracy of just taking it through as is. So grouping this together, I'm going to have 15 cos 54i plus 15 sine 54 minus 9.8 tj. So that's found my velocity. I'm then going to go and find my position, because it's all about position, isn't it? 20 meters out, how high, where it is. So we want to find our r, which is the integral of 15 cos 54i plus 15 sine 54 minus 9.8 tj dt. So I'm going to integrate it. That's 15 cos 54t plus, ti. I've got my I, didn't I? 15 sine 54t minus, now the 9.8t will become 4.9t squared j plus c. That's fairly straightforward. Now we need to find c, but we're calling this our 0, 0, obviously. So to find c, t equals 0, r equals 0, therefore c's got to equal 0. Because if r is 0, that t is 0, that's 0, that's 0, that's 0, so c must be 0. So we now have r equals 15 cos 54 ti plus 15 sine 54t minus 4.9t squared, j, our position vector. All right, first off, what do we know that? Well, we know the drone is 20 meters out horizontally. So that's what I'm going to talk about horizontally first. Okay, so we're going to look at when the R horizontal is 20 meters. So that means 15 cos 54t equals 20. So we're actually going to get our time. Let's go to menu, run that. What's it going to be? Do I want to solve in it? Do I want to rearrange? Look, I'm going to rearrange. I want to go t equals 20 over 15 cos 54. It's just simple. Make sure I'm in degree mode, of course. So here I'm going to have 20 on top. On the bottom, I'm going to have 15 cos 54. Execute. T equals 2.27 seconds. All right. We know one of the commenters' things was it took around 2 to 2.5 seconds after projection to reach the drone. So that first one, we're going, yeah, that's good, isn't it? We like that. We like that. It's a reasonable thing for him to say, I should say, isn't it? You know, we're talking about reasonableness of his comments. That one will be reasonable. And we'll make a statement about that at the end. The other one is about the upward direction. And you're like, oh, okay, what's going on there? So we're going to look vertically. Now, you can look at a few different ways. There's vertically. So R vertically is 15 sine 54 t minus 4.9 t squared. Vertically. So you might want to think and go, okay, well then at R vertically at 2.27, 15 sine 54 2.27 minus 4.9, 2.27 squared. Let's see what we get there. Delete. So 15 sine 54 times, how about I just do shift answer? So I maintain my decimal places. Minus 4.9 bracket, shift answer, close bracket squared, execute, 2.31. So I know it's 2.31 in the air at 2.27, but is it going up or is it going down? That's what we want to know. So I'm going to go to my graphic calculator. And I'm going to graph y equals 15 sine 54x minus 4.9x squared. That's really t's, isn't it? But that's on my graph. Delete. So I'm going to put in 15 bracket sine 54 close brackets x minus 4.9 x squared. Draw. Ooh, nice little graph. Now remembering x is t and y is height. Oh, my writing is terrible, sorry about that. So if we look at that, our little parabola going like that, when is it shift G solve? Well, let's go when, what would the height be when the time is 2.27? Oh, they've got it as 2.9, which is 2.3, isn't it? So it's actually here. That's the point when we're at 2.27. It's on there, so it's obviously going downwards, isn't it? It's on the downward of the peak. So this one, not this, sorry, moved my camera too much. This one is going to be not a good observation or comment. So we need to say that estimation for the observer, estimation of time is reasonable, but estimation of direction is not reasonable. Okay, because we've worked out that it was going downwards. And there's that question.